Welcome to this section. We are going to install TensorFlow with pip. TensorFlow 2 can be installed as one of these two packages right here. We have the simple TensorFlow and TF Nightly, that's TensorFlow Nightly. While TensorFlow is the latest stable release, the TensorFlow Nightly is a preview build which may be unstable. Also note that the TensorFlow version and the TensorFlow Nightly version both support CPUs and GPUs. Let's go ahead with installing TensorFlow, which supports the CPU, which is actually the default version since we all have CPUs. So what we do is we have pip install TensorFlow, and there we go. TensorFlow 2.5.0 is being installed. Now if you want to install TensorFlow but instead other previous versions, here you have a list of those versions, 2.50 right down to 1.00, and here you could see also the Python version which matches with this different TensorFlow versions. Supposing we want to install TensorFlow 2.3.0, then we'll just simply do pip install TensorFlow equal 2.3.0, and there we go. You see it starts downloading this TensorFlow version. Once TensorFlow has been installed, you could simply do import TensorFlow, and you see that works fine. Generally we do import TensorFlow as TF, so we have that, and then we could do tf.version, so we have the version, and there we go, 2.3.1. this is the current version present in this PC. As you may have noticed, here is the TensorFlow versions meant for CPU. Now if you want to work with a GPU, that is to take advantage of a GPU's computational power, then we'll install TensorFlow GPU, as you could see right here. So instead of TensorFlow, now we have TensorFlow GPU. And then notice that we have now this QDNN and CUDA which have been added compared to this CPU. We just had the version, Python version, compiler, and build tools. Now we have this 4 plus QDNN and CUDA. Advancements in science and business drive an insatiable demand for more computing resources and acceleration of workloads. Parallel programming is a profound way for developers to accelerate their applications. However, it has some challenges. The first challenge is to simplify parallel programming to make it easy to program. Easy programming attracts more developers and motivates them to port many more applications on parallel processors. The second challenge is to develop application software that transparently scales its parallelism to leverage the increasing number of processor cores with GPUs. In this post, the author discusses how CUDA meets those challenges. The author here is Pradeep Gupta, who wrote this post for NVIDIA's developer blog. So here we have that the CUDA programming model was invented by NVIDIA, and it addresses the challenges we spoke of previously. CUDA is a parallel computing platform and programming model for general computing on graphical processing units, that's GPUs. With CUDA, you could speed up applications by harnessing the power of GPUs. NVIDIA released the first version of CUDA in 2006, and it came with a software environment that allows you to use C as a high-level programming language. There are thousands of applications accelerated by CUDA, including the libraries and frameworks that underpin the ongoing revolution in machine learning and deep learning. And to solve the two major problems, we have that CUDA is easy to program, or we could say easier to program, and it's also easy to scale. Now let's look at the QDNN. The NVIDIA CUDA Deep Neural Network Library, that is QDNN, as you can see, DNN, is a GPU accelerated library for primitives of deep neural networks. QDNN provides highly tuned implementations for standard routines such as forward and backward convolution, pooling, normalization, and activation layers. Deep learning researchers and framework developers worldwide rely on QDNN for high-performance GPU acceleration. It allows them to focus on training neural networks and developing software applications rather than spending time on low-level GPU performance tuning. QDNN accelerates widely used deep learning frameworks including Caffe, Chainer, Keras, MATLAB, MXNet, Paddle, PyTorch, and TensorFlow. Now we could see clearly from here that the TensorFlow version is also related to the QDNN and CUDA versions. So supposing we're working with this version 2.3.0, Python version ranging from 3.5 to 3.8, then it means we would have to work with CUDA 10.1 and QDNN 7.6. To obtain the CUDA 10.1, we head to the NVIDIA developer site. On CUDA Toolkit Archive, we have these different versions of CUDA right here. Here we have CUDA Toolkit 10.1. Click on that. This comes up. Select your operating system, for example, Windows. Pick the version, Windows 10, and then local. So we get from this, and then we could now simply download this file right here. After downloading, here is the file we get, which we launch. We select the extraction part. That's fine. It's extracting. After extracting, this pops up, and then you're left with installing CUDA. After installing CUDA, you get into the installation folder. We have CUDA version 10.1, and then we get into this bin and copy the path to this bin folder. Then go to the control panel, system and security, system, advanced system settings, environment variables, go to the path, edit the path, and then we have this included right here. So as you could see, we've copied the path and pasted in here. We also do the same for this lib nvvp folder right here. So we copy this path and then we paste it in here. That's okay, that's fine. Our next step is installing QDNN 7.6. To do that, again, we go to the NVIDIA developer site, QDNN archive. Now we scroll down to 7.6. We see here we have this version for CUDA 10.1. Since we have 10.1, we're going to download this version of QDNN 7.6, which is this QDNN version 7.6.5 of November 5th, 2019. So we'll click on that, and then we select operating system. That's fine. Now what you need to do is to log in or join so that you gain access to this file, which you simply download. After downloading, there we go, we have this, which you can now extract. So yeah, we'll just extract this. We open this up, and this is what we have. Now NVIDIA also has this NVIDIA QDNN documentation, which will permit us install QDNN properly. So here we pick installing QDNN on Windows. You could always pick the operating system with which you're working with. So here we'll pick Windows. You have this prerequisites right here. Then you go ahead and download QDNN, which we've seen already. Then now we are at level of installing this on Windows. Now after unzipping, as we see here, we now copy this file, this qdnn.dll file, which is located in the bin folder, into this CUDA installations bin. So this means that in this QDNN, we copy this file, and then coming into CUDA's bin right here, we simply paste the file we just had. So we'll skip that. There we go. So here's our QDNN DLL file. We just copied from the QDNN bin folder. The next we get into include, copy this. Here we get back, we go to include, and then we paste. Continue, that's fine. Finally, we get back, lib, qdnn lib file, copy this. In here, we get to lib 64, and then we paste that in here. Now we've successfully downloaded and installed CUDA and qdnn. What we have to do is now install TensorFlow GPU. There we go. We have pip install TensorFlow GPU version 2.3.0. Run that. And that's fine. TensorFlow GPU has been installed. Now, as you could see, when we run this config.list physical devices GPU, we have this physical device right here. Then for CPU, see we have it. Now if we say TPU, we have this empty list. So now we've installed TensorFlow GPU. We've now looked at TensorFlow installation and TensorFlow installation when we are having a GPU. But it may happen that you don't have access to a GPU. That's where Google Colab comes in. Google Colab actually stands for Google Collaboratory. It allows you to write and run Python code in your browser and offers the following advantages: no configuration required, free access to GPUs, and easy sharing. So yeah, as you see on this notebook made available on collab.research.google, you have this sample code which works and can be tested online. So that's it. Now you could also have look at this TensorFlow 2 in Colab notebook right here. And as you could see, Colab has two versions of TensorFlow pre-installed, a 2 version and a 1 version. But Colab uses TensorFlow 2 by default, though you could switch to TensorFlow 1 by the method shown below. So there you go. Here you have freely available GPUs offered to you by Google. Google Colab also comes with TPUs, that's tensor processing units. So depending on your needs, you may want to use TPUs instead of GPUs.